done our question number 6 of exercise 1.5, that is about the verification of inverse of the product of two matrices equals to the product of two inverses here. So first of all, here the two matrices which we are going to use, that is A and D, and we have to verify that inverse of DA equals to the product of A inverse and D inverse. So these are the two sides here, the left and right hand side. So we will solve them. First we will take the left hand side, that is DA whole inverse. Left hand side, that is equals to DA whole inverse. It means first of all we will have to take the matrix D and A, we will multiply them, and then we will take the inverse of that resultant matrix over here. So DA whole inverse, how it can be found? First of all, I will take matrix D and A. I will take their product. Matrix D is 3, 1, minus 2 and 2. What is matrix A? That is 4, 0, minus 1 and 2. We are going to multiply in the same way. The row will be multiplied by the columns of the second matrix. So the row 3 multiplied by the first element of the column, 3 into 4 plus 1 into minus 1, then 3 into 0 plus 1 into 2, minus 2 into 4 plus 2 into minus 1. Then the second row will be multiplied by the second column. Minus 2 will be multiplied by 0 plus 2 will be multiplied by 2. We'll simplify this. 3 4 times 12, 1 1 times 1, minus 2 4 times 8, plus minus minus 2 1 times 2. 3 into 0 is 0, plus 1 into 2 is 2. Minus 2 into 0 is 0, plus 2 into 2 is 4. This is 12 minus 1 equals to 11. 0 plus 2 equals to 2. Minus 8 minus 2, minus minus, the plus sign will be of greater value. Minus 0 plus 4, that is equals to 4. So this is the matrix DA. Now we'll find the inverse of this matrix. As you know, the formula of multiplicative inverse of any matrix is equals to adjoint of that matrix, adjoint of DA over determinant of DA. So adjoint, here first of all I will write matrix DA. DA is this matrix 1, 11, 2, minus 10 and 4, divided by determinant of this matrix 11, 2, minus 10 and 4. Adjoint, how we are going to take? The diagonal entries will be interchanged here. In place of 11, this will be 4, and in place of 4, there will be 11. Plus 2 will be minus 2, and minus 10 will be plus 10. Because in adjoint, we interchange the diagonal entries and change the sign of other, means non-diagonal entries. So in the denominator, we will take its determinant. And how we are going to take the determinant? We are going to multiply the diagonal entries and off diagonal entries with the sign of minus. 11 4 times 44 minus 10 into 2 is minus 10 2 times 20. This is now 4. Okay, now 4 in minus 2, 10 and 11, and this is 44 minus minus is plus 20. This will be equals to 4 minus 2, 10 and 11. It's divided by 44 plus 20, that is 64. Now this determinant will be divided by all the entries of the matrix. So dA whole inverse equals to 4 divided by 64, 10 divided by 64, minus 2 divided by 64, 11 divided by 64. When we will simplify this, we will do the cancellation of this with table of 2. 2 times 4. With table of 4, we can do 4 1 times 4. And 4 how many times? 16 times 64. This can be cancelled with the table of 2. 2 5 times 10. 2 3 times 6. 2 2 times 4. This can be cancelled with the table of 2. 2 1 times 2. 2 3 times 6. 2 2 times 4. And 11 over 64 cannot be simplified more. So this is the left hand side, means we have found the inverse of the product of the two matrices dA. This is our left hand side. Now we'll solve its right hand side, and after the solution of that, whatever the resultant matrix we will get over here, we will have to compare that with this side, whether they both are equal or not. So now we are going to solve its right side. The right hand side is about A inverse into D inverse. This is our right hand side. A inverse into D inverse. It means here first we will find A inverse, then we will find D inverse, then we will multiply both matrices. So first of all we are going to find A inverse, that is equals to adjoint of A over determinant of A. So adjoint of A means we are going to put here the matrix A over determinant of A. We are going to find its determinant. Adjoint, how we can find? We will interchange diagonal entries and change the sign of non-diagonal entries. 0 has no sign. So 4 2 times here, that is 8, minus 0 into 1 minus 1, that is equals to 0. So 8 minus 0 equals to 8 here. 2 0 1 4, sorry, and this is divided by 8. Now this 8 will be divided by all the entries of this matrix. Matrix is 2 0 1 4. So it's divided by 8. This is divided by 8. This is divided by 8, and this is divided by 8. So this will be equals to 1 over 4, 0, 1 over 8, 4 1 times 4, 4 2 times 8. Now we will find its D inverse. The formula is adjoint of D over determinant of D. Adjoint of D. First we will put here the matrix D, that is given in the question. 3 1 minus 2 2, 1 minus 2 and 2, and this is divided by the determinant 3 1 minus 2 and 2. We'll take its adjoint. We will interchange the diagonal entries. This is now 2, this is 3, plus 1 is minus 1, and minus 2 is plus 2. This is divided by, we'll take the determinant, 3 2 times 6. This is minus, and minus 2 multiplied by 1, that is minus 2 equals to 2 minus 1, 2, 3. It's divided by 6 minus minus plus 2. 6 plus 2 is 8. Now this 8 will be divided by all the entries. 2 divided by 8. Here 2 divided by 8. Minus 1 divided by 8. And 3 divided by 8. We'll simply simplify this. 2 1 times 2 to 4 times 8. 2 1 times 2 to 4 times 8. Minus 1 over 8 cannot be simplified again. And 3 over 8 cannot be simplified more. So this is now the D inverse. We have now both the matrices, A inverse, that is here, and D inverse, that is here. We'll multiply both A inverse and D inverse to get the right hand side. First we write matrix A inverse, 1 over 4, 0, 1 over 8, 1 by 2. Then matrix D inverse, 1 over 4, 1 by 8, 1 by 4, 3 by 8. We are going to multiply both the matrices. The rows will be multiplied by the columns of the second matrix. So the row is here 1 over 4 and 0. That will be multiplied by 1 over 4 and 1 over 4. 1 over 4 multiplied by 1 over 4. Plus 0 will be multiplied by 1 over 4. Then same row multiplied by the second column. 1 over 4 multiplied by minus 1 by 8 plus 0 multiplied by 3 by 8. Here the second row we are going to multiply 1 over 8 multiplied by 1 over 4 plus 1 over 2 multiplied by 1 over 4. 1 over 8 multiplied by minus 1 over 8 plus 1 over 2 multiplied by 3 by 8. We'll simplify this. 1 1 times 1, 4 4 times 16 plus 0 multiplied by 1 over 4. If 0 is multiplied by any number, the answer is 0. Now numerator multiplied by numerator, 1 1 times 1, 8 4 times here, that is 32 plus 1 1 times 1, 2 4 times 8. Here 1 multiplied by minus 1, we will get minus 1. 4 8 times 32 plus 0 multiplied by 3 over 8, 0. Minus 1 multiplied by 1, minus 1. 8 8 times 64 plus 3 1 times 3 and 2 8 times 16. Now we'll see here, if 1 over 16 and 0 will be added, we will get 1 over 16. If minus 1 over 32 will be added in 0, we will get minus 1 by 32. Here this is 1 over 32 plus 1 over 8. So here the denominator, here is addition and the fraction is here. So we are going to take its LCM, 32 and 8. The LCM of 32 and 8. LCM of 32 and 8 is 32. 32 divided by the denominator, that is 1. 1 multiplied numerator, 1 into 1 plus 1. Then plus 32 divided by 8. 8 how many times 32? 8 4 times. 4 multiplied by 1 will be 4. Here 64 and 16. The LCM is 64. 64 divided by 64 is 1. 1 multiplied minus 1 is minus 1. 64 divided by 16. 16 4 times and 4 3 times. That is 12. We'll simplify this. 1 by 16. 4 plus 1. 5 by 32. Minus 1 by 32. 11 by 64. This is the right hand side and this is equals to the left hand side. So at the end you will write over here verified left hand side equals to the right hand side.